I do. Okay, so dilations, we have angle measures preserved. That means corresponding angles are congruent, links are not. However, we had a scale factor when we had dilations. It was image over pre-image, which is a ratio. And therefore, the sides will be, the links, we'll say sides in this case, links are in proportion. This is where 7.1 comes into play. Everything in this chapter is going to be in proportion. So what we've done in Chapter 7 is we're just doing a, what do I want to say? In-depth study of dilations. It's an in-depth study of dilations. Okay. Almost lost it. So with that said, because we've done that background work, we will not do the investigation. So let's go back to the smartboard notes that we had. All right. So if two figures are similar, corresponding angles are congruent. This is definition of similar figures. Corresponding sides are in proportion. The ratio of corresponding sides is called the scale factor. So we're building on previous knowledge. So and the scale factor was kind of shaky in the dilation section of what we did. I wasn't concerned because I knew we would revisit it in our similar figure. So this is a tie back to our transformations. If two figures are similar, then a dilation or a composition of an isometry and dilation. Isometries are congruent figures, should map one onto the other. So the algebra in this chapter is all about proportions. The chapter we did before was an in-depth study, technically, of our isometries because they preserve congruent measure. So we're wrapping up our Unit 4 project. After this, we're going to do a Unit 5 project, and that's going to involve your congruent triangles.
Are we going to do investigations on this work?
We don't have time, so I'm tying it into dilations, which we already know. All right, so the question is, are these two figures similar? In order to do it by definition, you have to check all the angles. Are these angles congruent? Yes or no? Yes. Are these angles congruent? How do we know? We don't. How do we figure it out? I take 110 and 50. I add it up. What do I get? And then what do I do? And if you do this on your homework, do I need to see this work? And what is that angle going to be? 20. So do they now match? What does this one have to be? 50. So is the first part of our definition matched? So we have congruent angles. Now, you have to, do you want to do big to little, or do you want to do little to big? Your choice does not matter. Bree, you make the decision. What are we going to do? Okay, so we're going to choose little sides, and then we're going to do big sides. So if I choose 9, what number in the big triangle corresponds to 9? Yes. Now, choose another. You want 12 or 6 this time? Okay, what corresponds to 6 in the other triangle? 8. And what's the last number in the little? We did 9. 12, and it corresponds to what? All right. It's important that you always put the little on top and the big on the bottom. Now, are these equal? We don't know. How do we figure that out? 3 goes into 9. 3 goes into 12. That gives me 3/4. 2 goes into 6. 2 goes into 8. What's this called? What am I doing? Simplifying. 4 goes into 12. 4 goes into 16. Are these ratios the same? So are these similar? Okay, this is our similar notation. Notice it's the congruent minus the equal sign. That means they are similar. So on your homework, you are going to have to determine if two figures are similar. In order to do that, you must check all angles. You must check the ratio of all sides. All right, how many degrees are in a quadrilateral? 360. How do I find this angle right there? 110, good. 135, 45 is going to be 10. Carry your 1, 7, 8, 9, that's 290. Then what? 360 minus 290 is going to be 0, 1632. I think that is going to be 7. So this is 70. All right, 135s match. The 45s match. The 70s match. Does that mean that this has to be 110? Yes. All right, so now that that's half the definition. What are we going to do next? Trevor, do you want to do little to big or big to little?
Little over big.
Okay, so we're going to do small over large. So Trevor, pick one small side.
15.
Okay, pick another small side. Pick another small side. Pick another small side. Okay, notice I put all the smalls on top, that way I don't mess it up later. Now, you've got to be careful. What corresponds to 15, Caitlin, in the other one? All right. Kayla E., what corresponds to 22? Okay, what corresponds to 10, Kayla S.? And what corresponds to 25? McKenna? 40. So now we have to simplify. 3 divides 15, 3 divides 24, 2 divides 22, and 2 divides 32. 3 goes into 15, 5, 3 goes into 24, 8. 2 goes into 22, 11, and 32, 16. Do I need to do any more?
No.
They are not equal, which means sides are not in proportion, so these are not similar. Any questions so far? Is this easy?
Yeah.
Then after this unit, Unit 6 does triangles, and then we're done with triangles. Because we've had so many projects this 9 weeks, I will not be doing a 9 weeks test. Yeah. Because we've had so many, and we'll probably have we'll have 3 projects, I think. All right, so I'm going to go to the next one. And what type of transformation maps L, K, M, N, this one onto this one? What's it called? Small, big? How do we go from small to big? What's it called? Dilation. All right, what's our dilation notation? Do you remember? Yeah, we need a, and this would be of L, K, M, N is equal to L prime, K prime, M prime, N prime. What do we need here? The scale factor. Where's our scale? How do we determine scale factor?
You have to do all that stuff.
Well, if I choose 6, what corresponds to 6? 8, divide by 2. I'm assuming there can. So it's a dilation of a factor of what? 3/4. Now, you dilated a floor plan, so we won't have that part on your next project. All right, so I'm telling you, look, I'm telling you these two triangles are similar. If I tell you this, what do you know? Corresponding angles congruent, sides what? In proportion. So, what is the measure of angle C? 100. What's the measure of angle E?
25.
What's the measure of angle A and angle D? How do we find it?
Yeah, that adds from there.
So we say 100 plus 25 is 125, then what?
It's 20.
8, 7, 5, 55. So they equal 55. All right, so now we have to, notice I now have variables. This is where the algebra comes in. So are we going to do big to little, Becky? You choose it. Or little to big. Okay, so we're going to do small, then large. So Becky, I want all my small sides. What are they? 7, 5, and y. All right, what corresponds to 7? X. What corresponds to 5? And what corresponds to y? All right, so this is, if you will do this and set up all your ratios, what you're going to find is you will find one ratio without any variables. You with that? Are you with me? So in order to solve for x, we're going to need to do 7 over x equals 5 over 8. And in order to solve for y, we're going to have to do 5 over 8 equals y over 19. You've got to use this in both proportions, otherwise you can't find x and y if you have two unknowns. So Nick, how do you solve this proportion on the left? 7 times 8 is equal to? Oh, you did this. I was looking for the other half.
Oh, X.
Okay, and you were right about 56. And then what do you do to solve? Divide by 5. So x is 56 over 5. All right, how are we going to solve this one, Leslie? You're going to say 5 times 19. 8 times y. Did you say 8 times? All right, so now we're going to say 19 times 5, which I have no clue. 90. So did you do 20 times 5 minus 5? That works. That's a distributive property, by the way. Divide, you're going to get 95 over 8. So, will these if I make up the problems, will the numbers be ugly? Yes, I like improper fractions. That saves you from going to a calculator. So now they're telling us that pentagon penta is similar to pentagon ribbish.
Wait, so what are those equal?
What is what equal?
Like quadrilaterals equal 360. What are like things over 4 equal?
That is a good question. This is the way you can figure this out. How many from this vertex, how many triangles do I have here? 3. So if I take 180 and multiply by 3, I get 0, 24. Guess how many degrees are in that figure? Is that pretty cool? Can you do that for any figure? Yes, but it's got to be from one vertex. In fact, that's a lesson that we would have had if we had gone in order in this textbook. But we didn't. Okay. So what do those silly little arcs supposed to mean? So if I let this be x, and I let this be x, do you agree we'd take 80, 130, and 86 and add them together? And we get 16, 17, 18, 19, 196. What do we do with 196? Not yet. We have to subtract it from 540. So this is going to be 10. That makes that a 3. So I get 4. We borrow from the 5. We get 4. And this is not. So that's 13 minus 9 is 4. So that's 344. Now what do? We take 2 into 344. And that's going to be 1. 14 is 72. So this is 172. This is 172. What's angle I? 130. What's angle P? R. 80. What's angle 80? S. What's angle B? What's angle H? Okay, now let's do large over small. So now I'm going to choose P. I'm going to choose 28. I'm going to go to 20. I'm going to go to N, and then I'm going to do 24. So I need these matched. Nick, you get to match them. What matches P? Yeah, I'm doing large over small, so we're looking at the small. What's P is on the side, I'm sorry. Little p. 7, what matches 28? A, what matches 20? There's our number. What matches N? 14, what matches W? 24. W. So here is our ratio. What goes into 20 and 12? Higher. 4 goes into 20, 4 goes into 12. So if I want to solve for A, I take 28 over A equals 5/3. To solve for P, P over 7 is equal to 5/3. The only reason why I reduce that is because the numbers are smaller and it's easier to do. To solve for N, I would say 5/3 is equal to N over 14. And to solve for W, I would say 24 over W is equal to 5 over 3. How many proportions do you have to solve? How many do you have to solve? 4 of them. So it's just, now we're supposed to create a similar figure by doing a dilation, but I'm not given anything I need. So if I were to say that the scale factor, if I were to tell you that the scale factor is 1/2, what are you supposed to do to each of these coordinates? Divide by 2, and those would be your new ones. So we just did a dilation, scale factor 1/2 about the origin. So if there are any in your homework, that is what we would do. So I think I'm going to go ahead and finish this on the notes. So we'll call this A, B, C, D. So C prime would be 3 over 2 and 1 over 2. D is -1, 1, 2, 3, 4, -1, -4. My D prime would be -1 times 1/2, -4 times 1/2. A prime, which is -5, 2. When we multiply those by 1/2, we would get -5/2. Put your homework on that desk. And then we would have 1. And if we wanted to do B prime, we would have 1/5. So we would have B prime would be 1 over 2 and 5 over 2.